We're now ready to begin section 2.3, but before we start, let's discuss what we've learned to this point. In section 2.1, we did the echelon method of solving a system of equations. In other words, we looked for x, y, and then we expanded it to a dependent system. Sadie? To a dependent system. So we had one solution, consistent, no solution, inconsistent, and dependent. Lots of solutions. And then, now this was all in its natural form, using addition, multiplication, and stuff to zero out one of the variables and making new rows. Well, that set us up for section 2.2, where we introduce the matrix. It's a construction of a system of equations where only the coefficients of the variables are used to construct that matrix. And this was great because we still use the echelon method, but we also use the calculator. If I could write with my pen, it'd be wonderful. So let's begin now with what we've learned and expand it to addition and subtraction of matrices. The matrices is plural of matrix. And okay, the first thing is we designate a matrix by a capital letter. In a matrix like A, B, etc. So we know that now from the last section. And now we're going to talk about understanding how to add and subtract. And we'll do some of this manually and then do the calculator near the end. Once you're taught the calculator and understand the concepts, though, the theory involved, then it doesn't matter when you use the calculator. So here we go. So the first thing is we designate description of a matrix by row column. So if I had 3, 2, 1, 6, -4, -21, well, this would be a 2, rows is 2, and columns is 3. So we say a 2 by 3 matrix. All right, the cross is sometimes stated as 2 cross 3, but I just say by. Either way is okay. Now, the rules that follow to execute the process of subtracting are as follows. First off, we have to have the matrix A must have, I should say B, matrix B, the second one. Matrix B must have the same row by column listing as matrix A. Okay, and then the steps are each element, matrix A, is added or subtracted and again I'm doing it backwards, with matrix B. Same row has to be same row, same column. And the action creates, a new matrix. All right. Okay. So we have to have first the same size, and then we do each row column element with the same row column element in matrix B, and then create the new term for the matrix of the addition or subtraction. So here we go. First, and now we're going to talk about recognition of type of matrix. Forgot about that. All right. So if the rows equal, if the number of rows equal the number of columns, we have a square matrix. If we have only one row, then we have a row matrix. If we have only one column, we have a column matrix. Right, because our first exercise examples is to recognize what they are. So let's begin with some examples. Find the size of the matrix, determine if it's square, column, or row. Well, we notice we have 3 rows and 3 columns. This is row 1, row 2, row 3, column 1, column 2, column 3. So we have a 3 by 3. They equal, therefore it is a square matrix. Next one, we have only a row 1. We have 2 columns, but we only have 1 row. So therefore we have a row matrix. So I didn't give you one for the other, so let's give you an example. This has 1 column. Therefore, it is a column matrix. There you have it. Depends what you get on your exercise, but there it is. So now we're understanding have to understand the concepts of equal matrix. Okay, well, matrix A must be equal to matrix B in each element in the matrix B. Okay, so in other words, all of A must equal B. Matrix A must equal matrix B in size and elements. That's a better way of saying it. All right, I think that's clear for you. So the reason we're doing that is to figure out the missing elements if a variable is used. Find the values of the variables in the equation. All right. So we have row 1, column 1. We have 3 equals 3. So that one's okay. Then on the next one, I have -1 equals x. So I'm going to write -1 must equal x to be true. And then on the next one, I have 0 equals y. All right. 0 equals y. And that is one of the variables that we know has to be true in order to have equal. And then our last one is -8 equals z. And there you have it. So in a matrix that is equal, rows and columns must be the same. Here we have 2 by 2s. And each element, matrix A must equal elements in matrix B. And we did that. So our solution is x is -1, y is 0, and z is 8. Of course, that's not the only one we're going to do. So here we have short terms in this one. So this is a 2 by 2, and this is a 2 by 2. Therefore, we can make equal matrices. So in the first one, I have s minus 4 must equal to 7. S has to be 11 to make it work. The next one is t plus 7 has to equal 7. So T must equal 0 to make that true. Now on the second row, first column, we have -7 must equal -7, which is true. And then we have 6 equals R, and that must happen. So S equals 11, T equals 0, and R equals 6 to ensure matrices. Right, nothing hard. So now let's apply to addition. And we said earlier, addition and subtraction, we take each of the elements and add them. Well, here we have a 2 by 3. See it? 2 by 3, and it equals that. So we're finding the values of the sum and finding what the A, Z, M, K are to make it true on the addition process. So let's take the first one, first row. A plus 4 plus, because it's a plus here, 6A has to equal 18. All right, does everybody see that we only took the first term, first row, first column? And now I'm going to combine like terms. 4 plus 7A equals 18. I'm going to subtract 4 from both sides, and I get 14. So A has to be 2 for the sum to be 18. Now we're going to do the second one. So on the second one, I have this, and -79. So let's see what we can do. So I'm going to have 12Z added to 4Z must equal -79. Sadie, 16Z must equal -79. Well, we're going to do a little math here. We're going to divide that -79 by 16. And we get Z is equal to, and we'll stop right there.